we have 243 million vehicles on the roads today. And those vehicles all take a form of liquid fuel. So while it's wonderful that solar and battery cars and hybrid cars are coming into their own, that's great. What do we do about the existing base of 243 million cars? We need to have a viable alternative to gasoline and a viable alternative to diesel fuel that we can just literally put through the same sort of supply chain. Pump it at your local gas station, put it right in the tank of your car, and drive away.
We're trying to show that if a high school team can produce algae oil, why haven't the major companies started selling it?
Right now, we're trying to differentiate the different types of algae and different bottles, because currently right now, we do not know if each bottle has algae or not. So in order to test it, we're putting samples through the slide so we can see the cell structure. And if there is a cell structure, then that means that there's algae growing.
Well, all we're doing is we're just simply returning to a technology that nature gave us millions of years ago, and now we're relearning how to make this oil and extract it to fuel our energy requirements. It's nitrogen. The absence of nitrogen causes the algae to produce oil.
As a stored energy.
Mm-hmm. Exactly.
So nitrogen is like the algae cheeseburgers.
Yes. Yes.
We are planning on filtering and drying. With the 5-micron filters, we'll be pouring the algae water into the filters to filter out the water and catch the algae.
It's a lot greener down at the bottom, isn't it?
Really?
Yeah. Go ahead, take a look.
This is extremely exciting. This is our first batch of algae, so this is a momentous occasion. This is the 3rd attempt, and this is the single bottle that succeeded out of our 8 bottles. So it's really, really exciting to finally get at least one bottle of algae that grew properly and that we can filter and kind of see what kind of algae we've grown.
Yeah, you can actually feel it on all the edges. It's coming out of all the pores.
Yeah.
Our rig worked perfectly.
And then we'll be scraping the algae off the side of the filters, and then I believe we'll be pressing that in an olive press.
Yummy. We got an algae tablet.
A perfectly dry algae tablet.
Yep.
Want one? While we don't have any oil today, that doesn't necessarily mean the next batch won't yield a lot, all right? Sapphire Energy has gotten back to us. The secretary said we are, quote unquote, favorably inclined to help you guys out. Yes! Yes!
So we have many different ways to grow algae, and when we're doing the genetic engineering, we typically grow the algae on plates and then in flask, and I'm going to take you through one of our growth rooms now. All of our algae start off on plates. When you're doing molecular engineering, what you want to do is get a clonal population, and that is a population of cells that are exactly the same genetically. And then these column systems that we have here are our own version of a turbidostat for growing algae, and they're also hooked to carbon dioxide. This is my favorite because it looks really mad science. So what you can see here is our large-scale, quote, large-scale growth facility, and we're growing different kinds of algae in here, again, in different types of media, under different conditions, and again, bubbling carbon dioxide through them.
We put our solvent in this big round bottom flask here, and it heats it up to the boiling point of hexane is 69 degrees. So we just heat it up a little bit over 69 degrees. So it would evaporate and recondense with this water circulation condenser. Once the solvent comes down, it's going to slowly extract the oil. And once it goes above here, it's going to go back down to here, and you'll see your oil in here with your solvents.
So over at Sapphire, it was really exciting. So they were able to help us reconstruct the growing and the culture of these different strains of algae.
To continue following our progress, check out indigoproject.com.